Okay, today is transformations. I'm going to start with a review of what you learned last year. You'd have an absolute value function, which was a V shape. Do you recall the V shape? And then what if you did this to it? -1 out on the inside there. What would that do to it? Right 1. And then what if you did a +8 over here? Up 8, okay? Well, the more complicated ones were like this: y equals 3, and then maybe a 2x, and then -4. Okay, that one's got 3 things happening. I always recommended to my students start on the inside. And then it's horizontal on the inside and vertical on the outside. So the 3 dwarfs saying hi-ho, hi-ho, well, we've got hi-vo. And it'll remind you that it's vertical on the outside and horizontal on the inside. Okay, so my question for you is, what order would these things A, B, and C? I'll give you a hint. It's not in the order A and then B and then C. Would you please write down what order you think it is? Now, if your iPad's not ready yet, just think for me. What should be first? What should be second? And what should be third? Okay, I hope you know that on any difficult math problem, starting on the inside is a good idea. I recommend that you do B first. And when you're done with B, then you move to the outside of the function. When on the outside of the function, you should do it in order with multiplies coming before adds and subtracts. Okay, so BAC would have been my top choice. Now, I hate to break it to you, there is another way you could have done it. This is one of the reasons that this is so complicated. It took a long time to teach you last year. You can start on the outside and do it in normal order first. And then, once you finish with that, move to the inside. So, yes, B and then A and then C would have been my top choice. There's another way. You could have done A and then C, and then when done with that, you could have done B. All right, but you can't just do it in any order you want. There's only certain orders. There's 6 possible ways we could rearrange that, and only 2 of them are right. Okay, so that's the old way. Now, here's a question that would be kind of a pain in the neck to do the old way, but we can do it really easy with the new way. Take a look at this, please. It's the second slide of the notebook for today. If your iPad has not got there yet, I understand. It's slow Wi-Fi today. Just keep it moving towards it. Now, your instincts maybe are like mine, where this is X and this is Y, and therefore I should stick in the X right there and stick in the Y right there. Unfortunately, that does not work. Okay, that would be if this was our original function. But see, what's happening here is this is our original function was, let's say, absolute value of x plus 3. Do you get how if I put in a 5 that then I'd get an 8? Does that 0.58 work for you in this function? Does that make sense to you? Okay, so then let's make a picture of what that looks like. That's a V shape that's been shifted 3 to the what? Left. Okay, so here's my V shape, and now I shift it 3 to the left. Actually, it should be more like this. That's your standard V, and now feed 3 to the left. Let's say it looks like that. Okay, then the 0.5 comma 8. Let's say that's right here. Over 5 and up 8 is like, let's say that's on my graph here. The question is, where should the 0.5 comma 8 move to once you do this to the function? Now, trying to actually take this function and do all of those things, like 3 times, no, that's not 3 times. On the inside, you can't trust it, so that's 1/3 vertical shrink. Does that ring a bell? Actually, horizontal. Sorry, it's on the inside. It's horizontal. It gets complicated, doesn't it? All right. Well, here's the new way. The new way is you take this and we say, oh, this is like f of x, right? If that's like f of x, then x, go ahead, what do you think I should do? How do I finish this? If I know 5 is x, and by the way, the other one's f of x, do you get f of x and y are kind of the same thing? Okay. Okay, all right. All right, so it sounded like you were thinking, yeah, that's like f of x, right? So it's kind of like, that's kind of like the x, right? Kind of like that whole thing is kind of like x, right? So then that if that whole thing is like the x, which is 5, then do you get that what's underneath that has to equal 5? And then you solve. What just happened there? The stuff that's scribbled out, do you get the stuff that's scribbled out is where there normally would have been an x. You know, f of parentheses x. Okay? Except we know what x is. We know x is 5. So we can say that this area in here is equal to 5. So 3x minus 4 must equal 5. That sounds like an equation. And then you solve it. Everybody, write that down by new x, and then solve it. If you're still waiting for your iPad, time to give up, get paper out. Or you could like make your finger bleed and then, no, let's not go there. Okay. So adding 4 to both sides, 3x equals 9. Dividing by 3, x equals 3. Raise your hand if you got 3. Okay. Now, you get what we're really doing here? We're taking the point 5 comma 8, which used to be right here, and we're saying where should it move to under these transformations? And x equals 3 is my new spot that it's going to be, over 3. And up some really big number. Now, I want you to think, why should the y of it be a really big number? Just think, if the original function, y, was absolute value of x plus 3, I'm going to change this from a y because it's just too confusing to have all these y's running around. I'm going to have it be a new function called g of x. G of x is this new function where we go 5 times as tall. That's what makes it go up so high. From its old height was here, now we're going to make it 5 times taller and then add 6 to it. So do you get that what I do is replace all of this with an 8? All of that is an 8. Because see, this is the y, and see, I already have my y right here, and what should I do to it? This is the y stuff. Do you get the stuff on the outside here is the y stuff, the vertical stuff? So what should I do to it? I should take 5 times my 8 and then add 6 to it. So just like last time, we replaced the stuff on the inside with x. We said that was like x, right? Then we take the stuff on the outside, that, and that's what we do to the y. So you put the 8 in right here, and we have 5 times 8 plus 6, which is 40 plus 6, which is 46. So my new point is 3 comma 46. All right, I know that was distressing for some of you. I can see lots of furrowed brows. You're giving yourself wrinkles when you do that, so stop that. You'll need Botox later. All right, so let's go to this one. And this is x. That part we already did. Try it. To be able to tell me what my new x should be. Piece of cake. Easy peasy. If you're not writing right now, this is not a good thing. Write me a little equation that involves that 14. Now I'm going to pair you up with somebody. I'm going to pause while I do that, and you can compare answers with them. Here's what you should have done. You should have taken the 14 and said that's this part. So 6x minus 4, not plus, minus 4 equals 14. And then you added 4 to both sides, 6x equals 14, in the end, x equals 3. Apparently, no matter what you do, the answer is always 3 for x. Well, at least it was last time, too. How many got 3? Raise your hand if you did. Okay, good. Then the other part. Have you caught on to this yet? The stuff that's on the outside of the function, This was the function. The stuff that was on the outside of the function is the stuff you're going to do to the y. This is the vertical stuff. So it's going to happen to this. So I put it in, this is f of x. And remember, this is f of x. F of x is 8, so this whole thing is 8. That whole thing is 8. So now I'm going to go 2 times the 8 and then add 14. That's actually a positive 14 there. Negative 2 times 8 is negative 16 plus the 14 is negative 2. So we had x equals 3. Weird. I'm sorry. The next answer is that. Okay. Weird. So 2. All right. So anyway, and it is negative. Thank you. Okay. So, and it's okay. I have made it a safe place to make mistakes. All right. So 3 comma negative 2 is your final answer. Raise your hand if you had the same thing as I did on that one. Okay, good. Okay, I think you're getting it. You're able to move a point based on this. Think of these as like directions. And if you had to do it the old way, can you imagine how painful it would have been to have to do this the old way, where we'd say, okay, now I want you to make it 1/6 as wide as it used to be. Take this point and make it 1/6 as wide as it used to be. And then you'd have to move it to the right. And then you'd have to make it negative 2 times as tall as it used to be. So double how tall it used to be, and then flip that to the opposite of. And then when it's all done, you'd have to add 14. So I think this new way is, even though it's new, I think it's pretty slick for making points move. So what about this one? Give that one a try. You shouldn't even need my help at all. You should be able to just zip, zip. Here's the new point. Compare it with the kid next to you. I'll pause for a second while you try that. So let's see if you did it right. First, you should have taken this 1 and put it in right there and said 3 minus x is equal to 1. And I can just solve that pretty quick by saying x must be 2. X equals 2. All right, then the y. The y is 2. So f of x is what this is, f of x. This is x. Okay, so then if f of x is 2, this is f of x, and that's 2. So this is 2. So then it's negative 16 plus 10, negative 6. Remember me saying that was the answer for the next one? Okay, anyway. So 2 comma negative 6. Raise your hand if you had that one right. Okay. Any questions? All right. Now you have learned to move points. What about a graph? Well, we could do it the old way. But it'd be very painful. Obviously, I'm ending with, like, we could therefore do it the new way, and I'll show you in a moment. But here's how you'd have to do it. You'd rewrite that and say that's like negative 2x plus 1. And then you'd say, okay, so I need to take this graph and do a reflection left-right. Well, actually, the reflection left-right puts it right back on top of where it was. You get what I mean? Left-right reflection doesn't do a darn thing here. And then this 2, that makes it do what? Which way? Horizontal shrink. So we have to make it half as wide as it used to be, but still the same height. Okay? And then we'd have to move it, what's this? Left 1. Everything moves left 1. So now it's roughly, it's going to get worse and worse, but roughly like that. Now I still have a whole bunch of things left to do. All of that and that and that. Okay, so let's do it the new way. The new way is where you would say a graph is really just a whole bunch of points, isn't it? And didn't you just learn how to move a point? So this is a point. This is your way to change it. It's just like you just did 2 minutes ago. Figure out where that point should move to. Well, let's do the x part of it, the new x. That's negative 4, and it goes in. I hope you got this now. That's where the x goes, right? So then negative 4 is equal to 1 minus 2x, and you solve. Weird. Whoa, that's weird. I can't write 2x. Okay, fine. And then I'm going to divide by negative 2, and your answer is 5 over 2. Okay, so everybody, you put 5 halves right there. That's the same as 2.5 if you like decimals better. Now would you figure out y for me, please? It's just like the problems you just did on the last set of slides. So this was 5/2 or 2.5. When you stick the y in, which is -3, and you stick it in for f of x, that whole thing is -3. Hopefully you got, this becomes +9, and then you add it to the 4, makes 13/2, 13/2, also known as 6.5. I'm going to do them as decimals. It's 2.5, 6.5. That's where the new point should be. 2.5 over 2.5, come up 6.5 is going to be like up there somewhere. Do we actually expect you to actually graph these points? No. But when you were all done, you would have this shape, except it's been totally mutated with all of these changes. So let's say it's upside down now and it's narrower and then whatever, it looks kind of like that or something. Okay. All right. So that's just moving one point, and of course you just keep doing that to all the other points. There we go. Now there's points, there's graphs, and then there's what other way you can show math? You did it for a whole class that started with an A. Yes, algebra. And so algebra, points, graphs, usually are mostly part of geometry. What's that other thing? What did you do in algebra? I almost said it. Equations. There you go. So if you have points and you have graphs, equations are kind of a big thing from algebra and algebra 2. So we just moved a point, and we just figured out that taking a graph and doing this was just moving points again. So what if they're equations? So let's talk about equations. Let's say you had this as a starting equation. And let's say that I wanted to do this to it. I wanted to take the function and go like this to it, and then multiply it by 2 also. And that'll make my new function. You could do it by points again, but how are you going to get a new equation for it? That's the question. I need another one of these. G of x is what? Well, you take this guy and you do all these things to it. If I take this guy and move it to the right 3, what will it look like now? Well, it was x plus 3, and then I move it to the right 3, and then those two battle it out, and it's plus 3 and minus 3 just makes plain old x. Can you shut that door for us, please? Thank you. And then we have to do this to my function. That's pretty easy, plus 7. Then we have to do this to my function, throw a 2 on the front, and there we go. There's my new equation. I took this equation, and I did all of this stuff to it, and this is my new resulting equation. Let me show it to you in another easier way. I wanted to talk you through what I was doing, but what if I just said, it says minus 3 in here, so you go minus 3 here. It says plus 7, so you go plus 7. It says times 2, so you go times 2. There's your new equation. You just have to simplify it. Get what I'm saying? We just do these things to this equation and simplify it. And then the minus 3 and the plus 3 cancel out and make 0, so it's plus 0, or just x. So there's my new equation. What? Oh, it's the circular motion that's getting me. No, it's not, apparently. Fine. I'm going to stop trying to erase it now. It says 0 in the middle, and you just have to know that. Okay, tech issues today. So this is just a resulting list of all the points that would kind of go with the graph. And all said and done, I think you've got the idea. And I think you're ready for tonight's homework. These, in case you're looking through them and you're like, he skipped that whole thing. It's because we already talked about them. What does that plus k mean? Think about it. Where's this graph going to move? Up k. What does this mean? Left k. What does this mean? Oh, sorry, h. Okay. Left h and right h. How about back to this one, the k again? What's that one mean? Down k. Okay, that's all there trying to say? If you named your dog K, then you could have a good reason to say that. Okay. How about this negative out in front? Is that vertical or horizontal? I just want to remind you about that. That's vertical and horizontal on the inside. Make sense? Okay, so what if we had to do this to this graph? Is it left, right? Is it horizontal? Or is it up, down, like vertical? It is horizontal. So do you get horizontally? I'd have like that answer. Okay. I don't think we need to go out through all of those. What? Oh. I think that's the box with a big, long, huge, gigantor description of how to do it. Okay. And at some point, someday, you guys will be able to have notes that are like interactive like that, where you could drag that open and see it if you needed to have the explanation. Right now, all you've probably got is a little white speck, I imagine. Okay. All right. So here is your homework. Now, in case you're wondering why some of them are circled, one of my colleagues wanted to help, and you know how sometimes there's some homework problems where they're like challenge problems and you don't really need to know how to do that kind, but it's a good stretch for you. And don't discount that. If we were lifting weights and you went into the weight room and you only lifted light weights, you would have some benefit, but it would be not exactly building strong muscles. You might build toned muscles, but lifting heavy weights does something for you. It actually breaks down the muscle a little bit so that it builds up stronger. Same idea with hard problems. If you only do easy problems, you are not building strength. You might be toning your brain, but you're not building that strength. Well, anyway, the ones that are circled, those are the ones that you need to know how to do. Well, unfortunately, in this assignment, you circled every single one of them. So, anyway, but I guess the point is you can't go home and say, oh, I don't get that, but I'm not worried about it because it's probably one of those challenge problems. If they're circled, you actually need to know how to do all of those. Okay? So for the future, as you look and you see ones that are circled, that's what it means. You really do need to know that kind of stuff. So if you don't get it, that is something you should worry about and figure out. Yes? What? Yes, you may. Okay. So number 1. This has this point right here, 2 comma negative 3, and we're going to move that point in several different ways. F of x, well, this is the x, goes right there. And so I'd say x is 2. We're more used to it when they're like this, when we would say this was 2. We'd have to solve a little equation. On this one, it's just as simple as x is this part, and there's nothing to do to it. X is 2. There we go. Now we got to figure out what y is. And y is f of x. F of x, this whole thing, that is f of x, and it's y, which is negative 3, coming from right here. So the negative 3 plus 3 makes 0. So 2 comma 0 is the first point. Now, could you have done this another way? Absolutely. But I'd like you to do it the way I showed you, because you got to be able to handle complicated ones. These are all very easy ones. You know, like the ones we started the hour with, those challenge ones, that's what you're expected to know how to do. These are like easy, slowly work your brain up to the final end product. Okay, so x minus 1. That's what the 2 is. So x minus 1 equals 2. F of x is this whole thing, is the negative 3. All right. Try to answer those first 1, and then 2's over here, I guess, and 4's right here. Why don't you answer those first 3 questions and then compare your answers with the kid that I paired you with for today, and see if you get the same thing for problems 1, 2, and 4. I'll pause for a second while you try that. Okay, so the answer for number 2 should have been negative 1 comma negative 3. I want you to just think about this for a second. Do you get that all they asked you to do was take the function and move it to the left 3? Do you get that wouldn't affect the y? See how the y doesn't change? Doesn't that make sense? And if I'm moving the function to the left 3, it was at 2. If I move it left 3, it's going to go over into the negatives. In fact, it's going to be at -1. Doesn't that make sense? I hope that makes sense. All right, how about problem 4? Mr. J.H., what did you get for problem 4? Yes. Oh, so you haven't had it done yet? I apologize. I'll get somebody else. Mr. T, what did you have for number 4? All right, 3 comma -3 is correct, sir. Nice work. That one was just moved. What's that? Right 1, which if you think about it, takes this one and moves it to the right 1, which makes it +3, and then it makes sense. 3 comma -3. If you really understand it, it will all make sense. Now, I know sometimes it isn't making sense, and that's just because you don't really totally understand it yet. Hopefully, you don't need to yet. We're just learning this. And we did just review literally a month's worth of material, plus added a new way to do things in one day. All right, this problem, don't overthink it. This first thing, you're supposed to put that on all 3 graphs. It's the square root function. It looks kind of like this. But it's not just a swoopy line here. It's made up of 3 points. Can you take each of those 3 points and do that little process that I just taught you? I hope so. But can you do it a faster way? I hope so. Isn't this taking the graph and moving it somewhere? Instead of thinking of this as, okay, I got to take the x and put it into the x function, and this is the point 1 comma or 0 comma 0, and I got to put that in for here, and then I got to put this in as the f. Just take the whole function and move it down 1. That's all this means. The -1 means move it down 1. Could you take each point and transmute it into a new point? Sure, but why don't you just move it all down 1? There we go. Save that complicated process that we learned for the complicated graphs. It's just a nice little parent graph that's been moved. Maybe this one's complicated enough that you might want to take its parent points and move them. Like this, let's say I took this point right here, which is at 4 comma 2. And I could say, well, the x is 4, so I put in x plus 3 equals 4 and solve it. X equals 1. And then I figure out the y for it. And this will be, this is f of x, and f of x is 2. And so 2 minus 2. 2 minus 2 would be 0, y equals 0. So my new point would be 1 comma 0. And that right there is my new point. Did I do something wrong there? It moved, it's supposed to move 3 to the left and down 2. Nope, it's just that it's 3 to the left and down 2. So here's where the first point is. I'm off a little bit. Here's where the first point is, and the second point, and that's actually this 4th point, except moved down and over. So there we go. Okay, this is an easiest homework assignment. This one, the only thing that's maybe confusing is you graph number 29 above it, you graph number 30 right below it, and number 31 you go above it again. And here's your parent ones. And then they try to make your life a little easier on this one by having the parent on each of the graphs. But some kids were like, where's the graph? This is the graph. This is what you graph your first question on. I know it doesn't have little like lines at every, making lattice points and stuff, but you can take each of these dots and move it according to this, apparently down 1. So you can graph it right on there. I'm totally roughing it, but that's basically where you graph it. On the little picture is where your graph is. Okay, that's enough guided tour of your homework. When it says today, that means that's actually tomorrow. So actually that'll be right tomorrow when it says today. All right, so anyway, stop when you hit that. You're obviously done with your homework at that point. All right, that's all I have for you for today, ironically.